Good day, my dear students. Our lesson today is about the solar system. You have to listen carefully because, as I told you in our last virtual face-to-face class, the discussion on solar system and the other remaining topics will be part of the coverage of our coming exam. Today, we talk about the solar system. The solar system consists of the sun and many smaller objects. The planets, their moons, and some of them their rings, and such other objects which in astronomical size could be just debris like the asteroids, the comets, and thousands if not millions of cosmic dust. Years of observation, decades of observation, and years of spacecraft exploration have revealed that most of these objects I mentioned to you formed together with the sun about 4.5 billion years ago, more or less. These objects represent clumps of material that condensed from an enormous cloud of gas and dust. The central part of this cloud became the sun, and a small fraction of the material, and you will know later how small is small. This small fraction of the material in outer space eventually formed other objects. During the past 50 years, about that, we have learned more about the solar system than anyone imagined before the space age. In addition to gathering information with the latest, very powerful new telescopes, we also have sent spacecrafts directly to many members of the solar system or the planetary system. You know, class, let me have my notes. Okay, you know, class, when we speak of planetary astronomy, that is the only branch of our science that in order to study the objects or get some samples of these objects, we have to go there up there. We have to travel and get samples. Just like what China the other day successfully landed its spacecraft. The name of the spacecraft is Chang'e 5. Right there, the other day, Tuesday, to shovel some rocks and bring them back to the Earth to have further and more studies to be done. And according to their news that maybe within 5 years, they can already China as a country can already have what we call manned spacecraft, and to put some kind of laboratory there and study more. And according to the news that someday China will become a space superpower. Now, so we have several space probes already. More than 20. As far as I can remember, you have Mariner 1, Mariner 2, probably there was 3, 4, 5, then Pioneer, the name of the spacecrafts, Voyager 1, 2, probably more than that. Voyager now is already nearing the boundary of the solar system, the Voyager spacecraft. And if we consider the most studied planet in the solar system, Mars, so many spacecrafts there and very sophisticated, because not an ordinary spacecraft. They are like robots. They are like walking laboratories doing a lot of experiments there. Like human beings, they are carrying laboratories, get samples, examine, then send the result to the Earth, to NASA in particular. I would like to mention some of these robots on planet Mars now. You have the Mars rover Spirit, Mars rover Opportunity, Mars rover Curiosity, the only space vehicle that has sent so many results to NASA, the Mars rover Curiosity. And we have now the Mars rover Pathfinder, or Pathfinder rather. Well studied. As I said, planetary astronomy is the only science where we have to travel and go there. Go there, closer, nearer, if not right on the object, on the surface. So there, our probes have penetrated the atmosphere of Jupiter, landed on the surfaces of Venus, Mars, of course our moon, Saturn's moon, Titan, the asteroids. So 2 months ago, you have there the spacecraft landed on one of the asteroids. Last year, it was Japan's spacecraft. The other, this year, it's the US spacecraft. Humans have set foot on the moon, return samples from its surfaces, and make some analysis. We have even discovered other places in our solar system that might be able to support some kind of life. And that is the purpose. One of the primary purposes of these space probes is to find evidences of any life form. It could be in the past or in the present. Okay. Going back to my notes so that I will be guided. Okay. Now, let us have an inventory of our solar system. You have the sun, a star that is brighter than about 80% of all the stars in our galaxy Milky Way. So the sun is brighter than about 80%. Of course, the 20%, much brighter than the sun and much bigger than the sun. And also, by far, our sun, the most the most massive member of the solar system. Solar system. In the solar system, the sun is the most massive. In terms of percentage, the total mass, we are going to get all the mass of the solar system. 99.80% of that comes from the sun. 99.80%. 99.80% of the entire mass of the solar system belongs to the sun. In other words, if we are going to remove all of the sun, the whole body of the sun, remove the sun. In other words, our solar system would be practically weightless or massless. If we remove 99.80%, how about the other planets? Well, in the case of Jupiter, this is the sun. This is the sun. Jupiter, this is only about 0.10%, the mass of Jupiter. Then the comets, we consider the comets to have masses also. Its contribution is only about 0.03%. All other planets, Mercury, Venus, Mars, planet, Earth, Saturn, Neptune, Uranus, all of them, all other planets, its contribution is only about 4%. Okay? And the moons, we combine all the moons, that's only about 0.00, there are 3 zeros, 0.005%. Very small. Then, if we consider the asteroids, then the cosmic dust, all asteroids, it will be 1, 2, 3, 4, 5 zeros. 0.00002%. So very small contribution. Okay. Now, most of the materials of the planets is actually concentrated in the largest one, Jupiter. We combine all the planets, all other planets. Even if we combine all the other planets, still not enough to have the mass of Jupiter. So the mass of Jupiter really is much larger than the combined masses of all other planets. Now, beside Earth, 5 other planets were known to the ancients. When we say ancients, even prior to the time of Galileo. So these planets, Mercury, Venus, Mars, Jupiter, Saturn, were already known. And because of the invention of the telescope by Galileo and others, 2 other planets were discovered, Uranus and Neptune. These 8 planets all revolve in the same direction around the sun. Okay. Same direction around the sun. Here, you have here the sun. You have the sun here, sun. That's the sun. And then, all other planets. Okay, so you have here Mercury, you have here Venus, you have here Earth, you have here Mars, then you have the outer planets, you have here Jupiter, then you have Saturn, then you have Uranus, and then you have Neptune. Okay? Between Jupiter and Mars, you have thousands, okay? Thousands of miniature planets, and these are what we call the asteroids. What happened to this one? What happened? Wait. Okay, my ink here. I have so much ink. Okay, I have so much ink here. Okay, so you have here so many miniature planets we call the asteroids. And of course, you have the other members of the solar system, the comets. Okay, all these planets move around the sun in the same direction. If our spacecraft, or if we are inside a spaceship, and the spaceship is above the North Pole, over and above the North Pole, the location of our spaceships, over there above the North Pole, we will be looking on all planets moving counterclockwise. And if our spacecraft is above the South Pole, okay, our spacecraft located above the South Pole, then we would be seeing planets moving clockwise. Okay. Then, all these planets, including smaller planets, not miniature planets, but smaller planets we call dwarf planets, of which among the dwarf planets, you have Pluto. They have their own, what we call, path, or they have their own traffic lane. They have their own. Each planet has its own traffic lane. It has its own traffic lane. Okay? It has its own traffic lane. So they have their own path. So there is no possibility that they will be colliding against each other because they have their own traffic lane. They move on that lane. Never will they collide against and among each other. Okay. Now, I mentioned to you Pluto as one of the dwarf planets. Not only Pluto, there are so many. You have Ceres, okay, as another dwarf planet, Eris, Makemake, Haumea, okay. Let me have my, okay. And every planet, while they have their own traffic lane, they also have their own speed. If we are going to calculate here, Mercury has a speed of moving around the sun 47.87 kilometers per second. That's the speed of Mercury. Next, Venus, 35.02 kilometers per second. Next, Earth, 29.78 kilometers per second. We are talking here of per second. In the case of the Earth, 29.78 kilometers every second, the speed of the Earth. Meaning to say, if you are going to, let's say, we have one town here in Negros Oriental, the city of Tanhay. When you travel from Dumaguete to Tanhay with a speed equal to the speed of the Earth, you will reach Tanhay in about 1 second only. That is how fast the Earth travels around the Sun. 29.78 kilometers per second. Other books rounded off this speed as 30 kilometers per second. Okay. Then Jupiter, 13.07 kilometers per second. Saturn, 9.69 kilometers per second. Uranus, 6.81 kilometers per second. Neptune, 5.43 kilometers per second. Pluto, 4.74 kilometers per second. Okay? And we can compute this one using the classical physics way of computing it. Okay? So, you have here, let's have the Earth. Mercury, Venus, Earth. Okay. The Earth moves. The Earth moves around the Sun in counterclockwise. One complete revolution around the Sun, one complete revolution is 1 year. And 1 year is 365.25 days. We consider 0.25 days because we get the average of time to travel. Average time to travel. You know, class, every 4 years we have February 29, right? Every 4 years we have February 29. Then after that we have February 28. Then another 28, February 28. Then another February 28. Okay, 29. Every 4 years we have a leap year. So I think 2020 we have February 29. You try to check on that. We get the average of this one. It's 365.25 days. We just get the average, or 365 and 1/4 days. February 2021 we will have 365. 2022 we have 365. 2023 we have 365. 2024 we will have February 29 again, that is 366. So 365 plus 365 plus 365 plus 366, you add them all, then divide by 2, divided by 4, because we have 1, 2, 3, 4, the result is 365.25 days. And so you have here speed, we use classical physics here, okay, so that we can just have what we call easy way of understanding how we got those values of the speed, distance over time, okay, as simple as that. Okay, but of course we use Kepler's law. There would be difference, but the difference is not as significant as it could be. Okay, so you have here distance, and the distance here, the distance traveled equals the circumference of the circle, 2 pi r, divided by the time of 1 year, 2 pi r, where r is the radius of the circle. The Earth moves, we assume that the Earth moves in a circular path, and we know the distance from the Sun to the Earth, from center to center, the distance is 149,510,000 kilometers. 149,510,000 kilometers. That is the distance from the Sun, and because it is moving along a circular path. If we assume that, of course, Kepler will give us elliptical. So that's why you have 2 foci there. But again, the difference is not what we call very large difference. Okay, for our own purposes of having an approximate speed, we will just use the circular path, not elliptical, because you know you are not, after all, majoring in physics. But for our BE physics students, we have to use Kepler's law to get the speed of every planet around the sun. So R here is the distance from the center, which is the sun, to the earth. So R, 149,510,000 kilometers. 2 times pi. Pi is equal to 3.14. So you just substitute, and year here, 1 year this is equal to 1 year, and you have that. Okay, that's why you have those speeds. And okay. So we will continue. Okay, just relax. And if we are going to make a drawing for all the members of the solar system, it will be like this, It will be like this, something like this, something like this. I will be using the blue, You have here, this is the sun. Then you have here Mercury, the orbit of Venus, the orbit of the Earth, the orbit of Mars. Then you have the Jupiter. Then you have Saturn, Uranus, Neptune. We'll just include Pluto. But Pluto here would be in a different orbital plane. Pluto is something like that. I will be using the red for Pluto. Pluto is somewhere something like this. Pluto is here. Pluto. And then another member, dwarf planet. You have here the Haumea. This one, Haumea. Okay? Then another one, you have Haumea. Then you have another one here, another, very far, they are at the rim of the solar system. You have here another one, another dwarf planet. The name of the dwarf planet is Maki, or Maki. And then another planet here, dwarf planet, its plane of orbit is something like this. This is the dwarf planet Eris. Okay? And then, so that is it. Of course, you have here the sun, then Venus, Mercury, Venus, Earth, Mars. Then you have here so many asteroids. Okay, so many asteroids. Wait, there's so many asteroids here. Or miniature planets. Not dwarf planets, miniature, very small. Okay, so that is how it looks like. Okay, they have a different plane of orbit. Now, each of the planets and dwarf planets also rotates on its axis, because the Earth, while the Earth moves around the sun, in a counterclockwise, the Earth moves around the sun, and the speed of moving is about 29.78 kilometers per second. Again, some books round that up as 30 kilometers per second. One complete revolution around the sun is 1 year. And while the earth moves around the sun, it rotates on its axis. And one complete rotation is 1 day. One complete rotation is 1 day. Okay, that is also the situation to other planets. Only they have different orbital speed and speed of revolution. They have different. As I read the values, they have different values. Okay? There are times that some of these planets will have a planetary alignment. But not all of them will be in one alignment. But because, as I said, they have different speeds. And they have different distance to travel. Okay? At most, in the past, they were able to have an alignment of Jupiter, Saturn, Uranus, and Mars, 4 planets. Will there be 5? In my lifetime, I have not seen one. Or I have not heard one. That there is such an alignment of 5 planets. Okay. Now, the 4 planets closest to the Sun, okay, are called the inner planets or terrestrial planets. Okay. And these planets are what we call have greater density compared to the giant planets led by Jupiter. Okay. Then, the next 4 planets, Jupiter through Neptune, Jupiter, Saturn, Uranus, Neptune, okay, much larger, composed primarily of ice, liquids, gases. In short, these planets are fluid planets. That's why their density is much, much smaller than the density of Mercury, Venus, Mars, planet Earth. So, because they are just fluid planets. Mercury, Venus, Earth, Mars, composed of rocks. They are the rocks planets. Density, more denser, much denser. Higher density. I hope I can have the density of these planets. Okay, I have the density of these planets. Now, in the case of Mercury, the density is 5.4. Mercury, I'm going to erase this one. Erase, 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 erase. Erase, erase. So, Mercury. Density. You have planets. Planets, Mercury, density. What is density? Well, to explain density, I'll just give you one illustration. And the illustration will be in the form of a question. Which is heavier? Which is heavier? A kilogram of nails or a kilogram of cotton? Which is heavier? Which is heavier? Which is heavier? A kilogram of nails or a kilogram of cotton? So, of course, unfortunately, some would say the nails. Now, of course, many of my students would say not one is heavier. Because you have 1 kilogram of nails, you have 1 kilogram of cotton, the same mass, therefore, not one is heavier. However, the 1 kilogram of cotton will have more cotton than a kilogram of nails. A kilogram of nails would be just a handful of nails. But a kilogram of cotton could be a sack of cotton. Cotton as cotton, not the cotton that is compressed. Cotton as cotton. You have several baskets of cotton to constitute 1 kilogram. You have more cotton than nails in terms of volume. Why? Cotton has smaller density. You need more cotton to constitute 1 kilogram. So we are talking of density. Cotton has a density that very, very small compared to nails made of iron. Mercury, the density of Mercury is about 5.4. 5.4 in terms of grams per cubic centimeter or gram per cc. Venus, next to Mercury is Venus. You have 5.2 gram per cubic centimeter. Then the Earth here is denser. Earth 5.5 grams per cubic centimeter. Then Mars here is the planet that has the smallest density compared to other 3 planets, the terrestrial planets. Because in the case of Mars, its density is only 3.9. Mars 3.9 gram per cubic centimeter. Okay? So, other planets, of course, you go to Jupiter. Okay, Jupiter, as I told you, Jupiter, Saturn, Uranus, they are gas planets. So that in the case of Jupiter, very large Jupiter, Jupiter is very large, yet its density is only 1.3 gram per cubic centimeter. Then Saturn, the density of Saturn is 0.7 gram per cc. Then you have Uranus, the density there of Uranus is 1.3, okay, gram per cc, okay. Then Neptune, 1.6 gram per cc, 1.6 gram per cc. And so, talking of density, of course, density is very important also to determine the characteristic, the properties of a material. Okay. And then, you have the moons, and so on and so forth. They have also their own density. But I told you that the first 4 planets, Mercury, Venus, Earth, and Mars, they are the rock planets. And the rest of the planets are gas planets or fluid planets. Okay, now, you have here a famous person. The name of the person is Carl Sagan. Carl Sagan. This is your assignment. Try to understand how Carl Sagan simplified the understanding of the solar system with respect to its size and distances. You will realize that with the illustration, simplification by Carl Sagan, you can understand more about the solar system. Okay? Okay. Our class this coming Friday which is a virtual face-to-face class, will be substituted by this lecture. Okay? Then I'm going to upload more recorded videos, recorded lecture discussion, so that from time to time you are going to listen. No need for you to go to the internet, go offline, as long as you have saved this recorded lecture discussion. Okay? Stay safe. God bless us all. Bye.